Hey everyone. So today we're going to be doing the second part of our forces in motion lesson, which is Newton's second law. So we are going to get started with that. For this, sometimes I'll be on the big screen, sometimes I won't, because I need to have my little drawing tools up from the program that I'm using to record this. So, Newton's second law starts with the saying that says the net force of an object is equal to the product of its mass and acceleration, or F equals m times a. So we're actually going to be looking at Newton's law kind of in a mathematical sense. We are going to be actually doing some math, so get ready for that. And then we'll kind of talk about one more thing before we actually dive right in. So first up is net force. So if we go back to the second law, it says the net force of an object is equal to the product of its mass and acceleration, or F equals ma. The net force, we need to know what net force is. We know what a force is, that's a push or a pull, but what is a net force? Basically, all it is it's the combination of all of the individual forces acting on an object. So in this picture, we have a little race car guy. And if we look at our arrows, we see that there are a bunch of different forces that are acting upon this little guy in his race car. We have 10 newtons pointing towards the right, another 10 newtons pointing towards the right. This is probably from the engine. This is maybe from his turbo booster. Okay. And then we also have 7 newtons of force slowing him down, pulling him to the left, probably from this parachute. So if we wanted to figure out what net force does this race car have, we would figure that out by getting a combination of all the individual forces. So basically, if there are 2 forces that are going in the same direction, we add them. If there's a force going in the opposite direction, we would subtract. So let me get out of here so I can get my drawing tools up. Okay. And let me see if I can make this a little bit bigger. Ooh, that's quite large, but it'll do. All right, so if we have this, the net force acting on an object is a combination. To get the combination, we have 10 newtons, 7 newtons, 10 newtons. So basically what we would do is the following. We would do 10 plus 10, that would be 20. And then we would subtract 7, and we get a total of 14 newtons. And we also have to say where it's going. Is it going left or is it going to the right? That would be to the right, because this side has more newtons of force than this one does. So this would be our answer in this scenario. Ta-da! Okay. So that's pretty much how we find net force. It is not too complicated, but there are a few more rules when we're finding net force as well. So we'll go back over here, present. And so, all right, so when we're finding net force, we already saw how to do it with our little race car friend. But basically, if there are 2 forces going in opposite directions, we find the difference between the 2. So we subtract. And that kind of makes sense. If this dog is pulling with more newtons of force to the right, and this dog is pulling with less newtons of force to the left, how are both of them going to move? Well, that toy is going to move to the right, but it's only going to move to the right with 2 newtons of force, because this kind of cancels out 10 newtons of this force. So we kind of subtract if they're going in different directions. Okay. In this case, the net force is always going to be greater than or equal to 0, but less than either of the individual forces. So whatever way the object is going to start moving is going to be less than these starting ones, but it's going to be more than 0. Over here, we have 2 soccer players. We have the guy on the red team. He's going to kick the ball at 125 newtons going to the left. Guy on the yellow team is going to kick it with, let's see. He's going to kick it with 75 newtons of force. So if we subtract and we get the difference, we would have a total of 75 newtons going to the left because the guy in the red is kicking with more force. Okay, so that's pretty much how we would find the net force if we have 2 forces going in opposite directions. Next up is if they're going in the same direction. So in this case, we have 2 brothers. They look like brothers. I'm making that assumption because they look very, very similar, almost twin-like. But in any case, these movers are moving a couch, and they're both moving it in the same direction. This guy in front is pulling it with 20 newtons of force. This guy on back end is pushing it with 25 newtons of force. So they're both going in the same direction because it would be pretty useless if you have movers trying to move it in 2 different directions. So if 2 forces act on an object in the same direction, the net force is the sum of the 2 forces. You're going to add them together. In this case, the net force is always going to be greater than either of the individual forces, okay, because they're moving together. They're working together. If there's a heavy object and you get a friend to help you out, it becomes easier. That's because you're adding your forces that are applied. So in this case, it would be 20 plus 25, and that couch is going to move with 45 newtons of force to the right. And that's pretty much it. So it's kind of intuitive. If it's going the same direction, you add them together. If they're going in the opposite direction, you would subtract. And then in the case where we have some going in the same direction and one going in the opposite direction, you add them and then subtract. And then there you go. So that's calculating net force, okay? When you guys do your exit pass, you'll have a few questions that are asking you about net force, kind of like calculating net force and saying, how will the seagull move? It's going to move in this direction with this amount of force. And that's important too, because remember, force is a vector. So we have to say, what's the direction? What's the strength? So you'll have a few questions like that asking you about finding the net force acting upon the object, or how is it going to move. But now we are going to get into the interesting stuff, which is Newton's second law. And actually, it may be easier to type it because I'm not the best at drawing with my mouse. But for Newton's second law, this is where we're going to be doing the math, okay? Again, the law states that force is equal to mass times acceleration. So we need to know what units that we're going to be using when we're doing our math, because I'm sure Ms. Henthorne, Ms. Mostella, Mr. Owen, they will always tell you you have to use units when you are solving anything, okay? You can't just put a number and then leave it. So when mass is in kilograms and acceleration is in meters per second squared, the unit of force is in newtons. Okay, so this is the unit of force that we're going to be using. So force we measure in newtons. It's named newtons because of Isaac Newton. He's the one who came up with all these laws. So this is kind of a rundown of what you need to know for in terms of units. Okay, force, its abbreviation in the equation is F, and we measure it in newtons. Okay, that's how you say it. This is the abbreviation for newtons. Mass, we can kind of simplify that as an M, a lowercase m. We measure that in kilograms. This is how you say it. And the abbreviation is kg. We don't say, oh yeah, that's 5 kgs, or that's 10 kgs. No, we still say kilograms. We say the word, but when we're writing it, we just use kg to simplify things. And then acceleration, we show acceleration with a lowercase a. The unit that we use is meters per second squared. Kind of looks a little crazy. Meters per second squared. So it's not just speed. Acceleration is how fast or how much you keep increasing your speed every second. So slightly different than just velocity or speed. Either way, we measure it in meters per second squared, and the abbreviation is m/s to the second power. Okay, so you can make this 2 a superscript, or if you can't figure out how to make your 2 tiny, just put a big 2. Especially on forms, it's pretty much impossible to get superscript. So m/s2 is fine. All right, so this is one important thing too. This is a good slide, but the biggest thing is right here, okay? Basically, it says Newton's second law proves that different masses accelerate to the Earth at the same rate, but with different forces. So basically, if you have a larger object, it's going to fall at the same speed, at the same rate as a smaller object. But when it hits the ground, it's going to hit the ground with more force. And that kind of makes sense, okay? Because force and mass are related. So we know that objects with different masses accelerate to the ground at the same rate. Earth's gravitational constant is 9.8 meters per second squared. This is going to be important in a later question, perhaps on your worksheet. So Earth's gravitational constant, meaning the acceleration that an object experiences if it's falling on Earth, which is all objects that we know of, it's going to fall with an acceleration of 9.8 meters per second squared. That's pretty much it. So that's that slide. All right, let's get into it. So for our questions, the first thing we need to do is figure out, what is it asking? Is it asking for us to solve for force? Is it asking for us to figure out what the mass is? Or is it asking us to figure out what the acceleration is? So we're going to do a bit of underlining on this. And let's see, I may be able to zoom in just a little bit. That didn't do very much at all. A little bit more. All right, that's slightly better. All right, so a 40-kilogram skater is pushed by a friend and accelerates at 5 meters per second squared. How much force did the friend apply? So I want to look at this question and figure out, what is it asking me? I can do that by looking at what I do know. So I'm going to look at this F, the M, and the A, and I'm going to try and figure out, do they tell me what the force is? And if so, I'm going to write it down. Do they tell me what the mass is? If so, I'm going to write it down. Do they tell me what the acceleration is? If so, I'm going to write it down. So I have this here. Let's see. Can I change this to a smaller point? Nah, okay. So we're pretty much looking for numbers at this point. And I see 45 kilograms. And I want to think back to myself, kilograms. What is that measuring? And I could look back here and I see kilograms, that's the mass. So I'm going to go back over here and I'm going to put 45 kilograms where it says mass. Okay. Then I see another number here. And it says, okay, 45 kilogram, we got that one. Pushed by a friend accelerates at 5 meters per second squared. Okay, so that's another number. Meters per second squared. I don't quite remember that, but I know that force is in newtons because Newton came up with all these laws about forces. So it has to be acceleration. So what I'm going to do is I'm going to have 5 meters per second squared. And again, if you don't need to put the 2 little tiny up top. It's fine as it is. Okay, So now I can figure out that it is asking me for force, because that's the only one I don't have. I have the mass, I have the acceleration, I don't know the force. So we have here, how much force did the friend apply? Okay, this is where it gets important, and I'm sure your math teachers will tell you the same thing. When you are solving these types of questions, you have to rewrite the equation. That is key, because it's going to keep you aligned with what you need to do, and it's going to make things very clear as to what the next step is. So I'm always, every single time I start one of these problems, I am always going to start by writing F equals M times A. Always, always, always. Okay, that is just to remind me, okay, this is the equation that I need to use. Then I'm going to fill in what I know, and I've already written that down over here. So that's pretty helpful for me. I can just look back. Do I know the force? Nope, so I can just leave that as F. Next up in the equation is this M. Do I know the mass? Ooh, yes, M equals 45 kilograms. So I'm going to type it right underneath, or write it right underneath. And we multiply it by the acceleration. Ooh, do I know the acceleration? Yep, okay, it's 5 meters per second squared. Perfect. Okay, so now at this point, we have F equals, and you just do the math. 45 times 5. You can do the math by hand, or you can just do it on the calculator, and you're going to get 225. And what is my unit for force again? I can't just leave it as 225. I need to put the force as newtons. Okay, that's pretty much it. Biggest thing for you to do is to remember, always start with F equals M times A. Every single time you solve this, I don't care if you think you can read the sentence and be like, oh yeah, I just multiplied 45 times 5. No, write out this equation. It's going to help you so much, because sometimes these problems aren't as straightforward as they seem. So we're going to move on to another example. This one says, a cannon shoots a 20-kilogram ball at a sailing ship, and when it hit the vessel, it applies 2,000 newtons of force. How much was the cannonball accelerating? So my goal is to do the same thing. I'm going to underline numbers and see where they fit. Okay, I have 20 kilograms. So now I want to think to myself, which of these matches with kilograms? Is it force, is it mass, or is it acceleration? I think back, oh, it's mass. So I'm going to type in 20 kilograms. Over here, I have another number. It's 2,000 N. So if I think back, N is newtons. And is it force or mass that is using newtons? It is, force or acceleration. It's going to be force. So I'm going to do 2,000 newtons. Okay, so it looks like I do not know my acceleration. So, like we said before, once you have all of these numbers written down, that's when it's time to actually write out the equation. F equals ma. So F equals m times a. Okay, now I start plugging in. But you'll notice that we're going to run into a little bit of a conundrum in a second. And we'll see why in a second. All right, so force is 2,000 newtons equals M is 20 kilograms times, we don't know what acceleration is. So that's a little problematic. And if you look, it's not like I can just do 20 times A, because I don't know what A is. So I need to do a little bit of equation rearranging. Basically, what I would do if I want to isolate this A and have A on this side of the equals, and I want to get rid of this 20 kilograms, so it's just A equals something, I need to divide each side by 20 kilograms. So basically what's going to happen is I would rewrite my equation looking like this. A equals F divided by M. Okay? Basically, I'm going to take, if we were to, actually, I'll go back a little bit. Oh dear. Let's see. There we go. All right. I'm going to do this with my very large pen tool. If I were to divide each side by 20, divide each side by 20, this would cancel out, and I'd be left with A equals, it's a little backwards, but that's fine, A equals 2,000 divided by 20. So basically what we have there is, okay, we're back. So after rearranging that equation, basically we're going to end up with this instead. Instead of F equals M times A, instead it's going to be A equals F divided by M. Okay, so if we follow that equation, now we can do exactly what we're normally used to doing. We don't know what acceleration is yet, so we'll just hold it with an A. We do know the force, that's 2,000 newtons, and we can divide it by the mass. Oops, that says 200. We need to make that 2,000. We can divide it by the mass, which is 20 kilograms. Okay, so then we do the division. We have 2,000 divided by 20, and we end up with acceleration is equal to, 100, and then we have our unit, which is meters per second squared. Okay, there we go. That's how we do the second one. So really, the key thing with this is figuring out, what are we solving for? Is it asking for acceleration, or is it asking for force? Is it asking for what the mass is? It really depends on what they're asking and the information that they give you. So now we have 3 examples, or 3 sample questions. We're going to do the same exact thing. Okay, I'll walk you through these 2 as well. Now would be a good point, if you want to, you can kind of pause this one and then try it out and then restart the video once you have it done. But this one is asking, what net force is required to accelerate a car at a rate of 2 meters per second squared if the car has a mass of 3,000 kilograms? So if you want, you can pause it now, figure it out, and then play when you're done. All right, so let's figure out what it is. So again, the first thing you need to do is always start with that F equals, because this is a blank slate, F equals, M equals, A equals. That I find is the easiest way to organize yourself. So then we look at the question, we look for numbers. I see 2 meters per second squared here. So meters per second squared clues me in that that is going to be acceleration. Okay. Again, if you're not sure, you can always look back at, let's see, this, nope, not that slide. This slide here. Okay. Meters per second squared. Oh, that's acceleration. Makes sense. So heading back to this question, we have 2 meters per second squared. I'm going to write that down by acceleration. Okay. I also have another number here, 3,000 kilograms. I know kilograms, that's mass. So I'm going to write 3,000 kilograms. And since this is the only one we don't know, it looks like I'm trying to figure out what the force is. And that makes sense because it's literally asking what net force is required. So we know force. Okay. Then I'm going to write out my equation again and then fill in what I do know. Force equals mass times acceleration. I don't know the force yet, so I'm just going to leave it as an F. I do know the mass. The mass is right here. It's 3,000 kilograms. And I'm going to multiply that by, here's the A. A is 2 meters per second squared. Okay. And then I solve. 3,000 times 2. Force is going to be equal to 6,000. And then we have to put the correct unit, which is going to be newtons. And there you have it. Okay. Pretty straightforward if you follow these steps. All right. The next one is asking, an 8-kilogram bowling ball would require what force to accelerate down an alleyway at a rate of 3 meters per second squared? So again, if you'd like to, I'd pause here, try this one out on your own, and then play again when you're ready for the explanation. All right, so again, always start with F equals M equals A equals. Okay, it's the best way to help you organize what you know and what you need to solve to then figure out what equation you need to use. So we have F equals MA, got it. Okay, perfect. Numbers, we're looking in the question for numbers. We have 8 kilograms, and I know kilograms is mass, it's the unit for mass. So I'm going to put 8 kg by the M. Then, blah, 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 blah. Okay, another number, 3 meters per second squared. I know meters per second squared is the unit for acceleration, so I'm going to put that there. Okay, great. And then force, don't have anything, so that's what we're trying to figure out. So again, I always go right back to my trusty equation. F equals M multiplied by A. You can either use the asterisk, you can use the X for multiplication. It really does not matter. Either one indicates that you should be multiplying. All right, so still don't know what force is. That's what we're trying to figure out. Mass, I do know. M right there that I need to fill in is 8 kilograms. So I'm just going to substitute that M for the number that represents M. That's what the actual number that is what we're using for the variable. We're going to multiply it by acceleration, A, and that is 3 meters per second squared. And then I do the math, 8 times 3, and we have 24. Think again of what the unit is. If it's force, newtons. There we go. Okay, so for these so far, they have been pretty straightforward. They are all finding out what the force is. Now, we're going to do a practice problem that's kind of similar to the one, where was it? Over here, where we had to figure out acceleration. Now, if we look at this question, it's asking us what is the mass of a truck if it produces a force of 14,000 newtons while accelerating at a rate of 5 meters per second squared. So kind of think back to what we did when we needed to define the acceleration. You're going to do something very similar for mass. So again, you can pause it, give this one a go, and then press play when you're ready. And basically, we are going to start this one the same as usual. F equals M equals A equals. Okay, we always start. Doesn't matter what they're asking for. Always start by writing out your variables and what you know versus what you don't know. All right, it says, what is the mass of a truck if it produces a force of 14,000 newtons? Well, it says force, 14,000 newtons, so I'm going to write that down for my force. Okay. Then it says, while accelerating at a rate of 5 meters per second squared. I know meters per second squared is acceleration, and it says accelerating at a rate. So I'm going to type in for my A, 5 meters per second squared. All right, so it looks like I do not know the mass. Again, as soon as we figure out what F, M, and A are, then we are going to write out our equation. F equals M times A. But here's the catch. I'm not trying to figure out what F is. I know what the force is already. I need to figure out what the mass is. So if I'm trying to figure out what M is equal to, right now it's currently multiplied by A. So I need to get this A out of here and on the other side of the equals. So what I'm going to do is divide this by A and divide F by A as well. So basically my new rearranged equation is going to be M equals F divided by A. There we go. So just like when we did acceleration, it would be A equals F divided by M. To figure out the mass, you do M equals F divided by A. And you follow that equation. It's just our original equation rearranged, trying to figure out a different variable. So we don't know the mass. That's fine. We're going to leave it with M equals F over here. We do know what F is. It's 14,000. So I'm going to type that in. Newtons. And we're going to divide that by the acceleration, which is right here. And our acceleration is 5 meters per second squared. Okay, there we go. And I do the division, and again, you can do the long division if you so choose. You can do it on a calculator, that's fine. 14,000 divided by 5 is going to be M equals, oops, sorry, this should have been a lowercase m. M equals 2,800, and then again the unit. If you're not sure of what the unit is going to be, you can always go back to this slide. Slide 18 is going to be your best friend. If I'm trying to figure out the unit for mass, I look here. Mass is kilograms. Okay, so I'm going to go back to my original slide. Here we go. All the way down. Okay, and I am going to type in kilograms. Done. Okay, so on your exit pass, you have a few of those questions right over here. So what force is required to move a sled? Some of them are multiple choice. The last one is type in your answer. So make sure you write the unit. If you don't put a unit, it is not correct. Okay, and make sure it has to be the correct unit. Obviously, you should use your notes when you're doing the exit pass. That's kind of a big help. Okay, so that is Newton's second law. It's actually pretty math-based. It's just force equals mass times acceleration. So it's really just kind of understanding the relationship between an object's force and the mass of the object, as well as how fast it's going, or its acceleration. So that's that. Tomorrow, we are going to do Newton's third law, which is kind of a very abstract one, but it's also the shortest one, so that's good. All right. Again, don't forget, exit pass. Best of luck. If you have any questions, you can always leave a private comment, and I will try my best to get back to you. And that is it for now. So have a good one, guys.